Okay, this first video is gonna review simplifying radicals. If you can get to where you can simplify radicals, that's really the basis of everything we've kind of learned in this unit when it comes to working with square roots, cube roots, and fourth roots. So to kind of maybe start from the beginning a little bit, we know of numbers like 36 or 9 or 81. These numbers are special because they come from the product of a number squared. So 36 is 6 squared. 9 is 3 squared. 81 is 9 squared. So because of that specifically, we can then, for instance, take the square root of 36. And that would be equal to 6 because the product of 6 times 6 is 36. So we're kind of undoing the fact that we had squared something. Square root of 9 would be 3. Square root of 81 would be 9. So numbers like 36, 9, 81, all of these over here, and of course they go past this, but all of these are perfect squares. So when I turn around and I'm given a number like 180, 180 does not have a perfect, or 180 itself is not a perfect square. So there's not a number that I take times itself that would give me 180. However, there are numbers off of this list over here that would potentially go into 180. So you might figure out that 4 does, or 9 does. But the goal is always to find the biggest number off of the list that goes into it. So hopefully we figure out that 36 would be the biggest perfect square. So 36 times 5 is 180. If it makes you feel better, you could even split it into 2 separate. But by breaking it down this way, because I found 36, I know the square root of 36 is 6. The square root of 5 is not going to simplify down any nicer, so it would just have to stay the square root of 5. Okay, so 6 square roots of 5 and the square root of 180 would be equivalent to the same value or same decimal. Okay, if we do a cube root, we obviously would want to make sure we know all of these perfect cubes. Something like 8 is is 2, raised to the third power. So 2 cubed is equal to 8. 125 comes from taking 5 cubed. So if I turn around and do the cube root of those numbers, the cube root of 8 would be 2. The cube root of 125 would be 5. So something like 56, I would want to think what number off of this list, or it could be something beyond, but I kind of, expect that you know these. What's the biggest number on that list that would go into 56? And again, it might take some dividing out in your calculator, but hopefully you end up figuring out that, 8 would go into that. So 8 times 7. So again, we're taking the cube root of 8 times 7. So again, if you wanted to, you could make this the cube root of 8 times the cube root of 7. So that's kind of the same thing here. The cube root of 8 would be 2. I cannot do anything with the cube root of 7, so it would stay as the cube root of 7. So 2 times the cube root of 7 and the cube root of 56 would be equivalent to the same value. Okay, and if I throw variables into the mix, obviously I want to think about my number. So the 27, we could break down into 9 times 3, because 9 is a perfect square, and it's going to be the biggest perfect square that goes into 27. So the square root of 9 would become 3. I always kind of I know that the 3 is going to be left inside my square root here. I can't simplify that any further. My x to the fourth. So there's a couple ways you can think about it. The way I would talk in class normally is that if I have 4 x's, I can make 2 nice groups. So that would come out to the outside. I would have no x's left on the inside. We can also think about it as, well, how would I rewrite this in an exponential form? So we would have it as 4 over 2. So x to the 4 over 2 would end up being x squared. So that's coming out all nice. And then, you may have learned a long time ago, or back in Algebra 1, your teacher might have explained that if you kind of draw out all your 4 x's, you can make 2 groups of 2. That product is what's making a square root. Over on this other example, we have a cube root of 250. Hopefully you would figure out that 125 times 2 is 250. And then we have x to the 5th. And we're doing a cube root. So cube root of 125 would be 5. If I have 5 x's over here, that would mean that I could kind of think about it as x cubed and x squared. So that cube root of x squared, that is going to become just an x. And then that x squared, I can't, make a nice cube root out of that. So those 2 x's are going to stay inside my cube root. So just so that's written a little bit nicer for you, that would be 5x times the cube root of 2x squared. That would be my final answer there. Okay, so hopefully watching some of those extra examples will make radicals a little bit easier for you.